Hi everyone. Today we have two amazing researchers who published their work in the Journal of Cephalalgia. And congratulations on article of editor's choice with Journal of Cephalalgia International Headache Society. We have Dr. Russo and Dr. Zorrilla today with us. And I would ask first, please, can you please tell us a little bit about yourself for our audience?
Hi, thank you so much for having us on. It's a real honor to have been selected for uh, as the paper of the month. That's fantastic. So I'm Andy Russo. I'm a professor at the University of Iowa. Iowa, for most Americans, is something that's a vague idea. It's in the middle of the country that people usually fly over, but we love it here. It's a great place to do research. We have great students here, like Erik, who's joining us today. I'm in the Department of Molecular Physiology and Biophysics and Neurology. So I've got interested in migraine about, oh my goodness, probably more years ago than Erik's been alive. But it's been a real pleasure to see the field move along.
That's
I'm Erik.
amazing.
I recently graduated from the neuroscience PhD program, so I'm a freshly minted PhD researcher. I am Andy's most recent graduate, and my project was based off of the work that was done in Andy's lab for many years, and I am very grateful that he has given me the opportunity to put my own twist into finding a research project that falls in line.
Thank you so much. And we are very grateful and very interested. How did you come to do this work? I heard that some fantastic story behind it. Please, Dr. Russo.
So yeah, that's a great question. Is a convergence of different threads that on its own would have just been pieces of string. I love this analogy. But together, we actually wove together. I'm not a weaver, but I imagine how it's done. Weave together a story. There is a newly formed company with a University of Iowa graduate. It's called Schedule One Therapeutics. And George Pappas, the CEO, and at that time, the only employee of that company, it's a company of one, came to visit me because he was interested in applying cannabinoids to migraine. And because I'm at Iowa and he's an Iowa grad, we connected. We talked Hawkeye sports. We talked about life in Iowa. And I said, George, I don't have the bandwidth to take on this project. I love this idea of yours going after cannabinoids and migraine. I had a postdoc though, Anne-Sophie Wattiez from France in my lab, I've been to get her ready to move on to form her own lab. I thought this would be a perfect project for Anne-Sophie. And so Anne-Sophie just jumped on it and she's excited by it and got a couple grants from the Migraine Research Foundation, from NIH. And so she got this project rolling. And then right about then, the third of four threads came together. And that's this guy right here. This is right when COVID struck. Erik said, I'm really interested in cannabinoids and migraine. I went, no way. Seriously? I mean, I've never seen anybody as passionate about cannabis, and I mean that in a good way, as Erik. And so he came in and he worked with Anne-Sophie, and together then they got this project rolling. And the fourth thread, I told you it's quite a story. The fourth thread of this story was Arn van Mag. Oh my goodness, he has more last names than I can remember. Arn van den Magdenburg in the Netherlands. He and I have been talking for a long time about wanting to collaborate together because he does migraine genetics. I'm a molecular biologist, geneticist at heart. Turned out that George Pappas, the first thread, the CEO of the company, had also contacted Arn, and Arn was doing some studies with George. And unbeknownst to us, he was getting the same results we were in a totally different system. And so then Arn and I talked and said, let's combine our stories together into one paper, because now we have a couple models and he has a totally different model and much more impactful and I think translatable. And so I think that was the final thread that brought together the passion of Erik, the interests of Anne-Sophie, the motivator, George, and then Arn and I were able to put this all together.
That's such a magic story. And I believe that Erik was the one who did a lot in methodology and doing some work on the ground, right? Could you tell us a little bit about methods and what was done?
Sure. So from our part of the project, we saw results from two different migraine models using CGRP, so calcitonin gene-related peptide, and the nitric oxide donor SNP. Those were two migraine models that we used. We also used a combination of different behavioral assays to test migraine-like symptoms. So the first one is the light-dark assay, where we test light aversion, which is a mouse surrogate of photophobia. And that's a common symptom that a lot of migraine patients report. We also use the automated squint assay, which measures spontaneous pain. And that we basically measure the difference in the mean pixel area of the mouse. So that will give us a readout whether or not we can determine if the mouse is in pain. This has been reliably published by our lab before, where we administer CGRP and the mouse has a reduction in mean pixel area. And finally, we use tactile hypersensitivity using the Von Frey assay, and that measures allodynia. We also used a combination of adverse effects assays. So the first one is we use the light aversion for anxiety. We also use the open field assay, which also measures anxiety-like symptoms. Y-maze for assessment of memory. We use the tail suspension for depression-like symptoms, and finally the rotor-rod assay for motor function. And the reason why we wanted to include these assays is because although we were seeing positive results in the first set of experiments that I mentioned, it's also very important to measure, whether there are any adverse effects, because the main goal of the research that we do is to hopefully have this apply to humans. And if there's any adverse effects, those need to be set up front.
That's great methodology. And also in the article, it's interesting description that maybe in results, not all symptoms responded in the similar way, which is fascinating to see for me as clinician. So maybe if Dr. Russo can give us your perspective on that, why did we see that in your opinion? Where does it lead us?
Yeah, actually, the fact that that the cannabinoid combination did not work for every test we did is in a very, I think it's very reassuring to me that because I don't think there'll be one ring to rule them all, to use Lord of the Rings terminology here, to cure all symptoms of migraines, to cure all migraines. If we'd hit a home run with finding the one ring with this combination of two compounds, cannabidiol and tetrahydrocannabidiol, THC, I probably wouldn't even believe the data. It's been too good to be true. So this is believable. And what that means clinically is that we're not done yet. There's some room for improvement. I'd be the first to say that we have not found the one ring or the magic bullet to cure migraine in all people or to cure all symptoms of migraine. We're really excited that we had the luck that we did to find a combination. And I think that the fact we needed a combination of the two, I'll let Erik talk more about.
Sure. Kind of adding on to what Andy was saying, I think one of the most valuable parts of my training as a PhD researcher in Andy's lab is to believe your eyes and to always be skeptical of the data. So oftentimes, if we're very passionate about something, we want to believe something, but if the data is taking us in a different direction, then, as Andy always told me, the data is the data. And that's really reassuring. I think besides all of the different combinations and different behavioral readouts that we found, the most interesting finding, in my opinion, was the fact that we needed a combination of CBD and THC in order to see the rescues in the different behavioral assays. So what I mean by this is that we tested the same combination of CBD alone and THC alone, and did not see a rescue in light aversion, for example. However, when we combined the same doses, we see that there was a rescue. And this is actually not something new in the field. Maybe it's something new in the migraine field, but in the cannabinoid field, there's this concept called the entourage effect. And what the entourage effect states is that cannabinoids, THC, CBD, and all the different types of cannabinoids, they're working together either for a positive benefit or for something negative. They're either enhancing their effects or dampening each other's effects. And that's something that clinically is seen, and now we're seeing it in the migraine field. So that was also very reassuring.
That's very complex issue with disease by itself, right? Has so many symptoms, and then you can use different combinations too. So we're very grateful that you're looking into that. And which symptom did respond?
So for the CGRP and the SNP model, so migraine without aura, the project was divided into migraine without aura and migraine with aura. I'll break them down. But for the migraine without aura, for the CGRP and for the SNP, we saw a rescue in light aversion. And we also saw a rescue in spontaneous pain, so the automated squint assay in male mice only. For the tactile hypersensitivity, we saw no rescue in none of the combinations tested. For the migraine with aura, which was done by the group in the Netherlands using optogenetic cortical spreading depression, we also see that the 100-to-1 rescued in the mouse Grimace scale. All around the board, we see in all three models, so the CGRP and the SNP, migraine without aura, and in the cortical spreading depression, we see that in none of the adverse effects assays, the doses tested resulted in a negative outcome. And that's very interesting because ultimately what it tells us is that we're seeing, something positive and something that falls in line from two different groups in two different continents. And the stories line up.
Yeah.
That's wonderful. And how long the model was exposed to the treatment? Would it be role in the future into seeing, for example, for allodynia, for tactile stimuli, if there are changes with how long model uses the substance? And what will be, in your mind, another question for the future to continue this work, and maybe even different areas for treatment, right? I know you're working in so many wonderful directions already, so super exciting.
Yeah, I'll start that off. What you're getting at is a fantastic question, and you need to come work in my lab to do all this.
Thank you.
Yeah. So the way that our experimental model was set up is that we pre-treated the mice 60 minutes before with cannabinoids or vehicle, and then 30 minutes after that, we administered the migraine trigger, which was the CGRP or the SNP, and then we tested. So we're pre-treating with cannabinoid and then administering the migraine inducing agent. I think a very valid question would be if we were to flip that. So if we were to administer CGRP and then give it the cannabinoid treatment to see if it, rescues any migraine symptom.
And also, we haven't done the continual treatment, like injecting the mice repeatedly day after day after day and seeing what adverse effects there might be, or would there be a rescue, or there be tolerance built up in the mice. So those are all very good, very valid questions at the time.
Fantastic. And I heard some very interesting chemicals Erik mentioned, maybe for the future research.
Yeah, so the cannabis plant has over 100 different types of cannabinoids. CBD and THC are just two of them. So we're barely scratching the surface. Now, the cannabis plant doesn't just have cannabinoids. It also has a specific class of aromatic compounds called terpenes. Terpenes aren't just limited to cannabis, but they're also found in a lot of different plants and foods that we consume. Limonene, for example, is a terpene that is found in lemons and lime. Pinene is found in pine cones, etc. So I mention this because a lot of cannabis plants have specific combinations of different cannabinoids and different terpenes, and these molecules have their own physiological effects on the body. So BCP is a terpene which is found in pepper, and a lot of studies have shown that it has anti-inflammatory effects. So it could have some sort of applicability in any neurological disorder where there is some sort of immune cell dysregulation or inflammation. So moving on in the future, I think it would be very interesting, both clinically and preclinically, to do experiments looking at terpenes, cannabinoids, flavonoids, and other different compounds of the cannabis plant to see whether or not there are any, positive and or negative results. I think this could help clinicians and researchers and everyone in the space better determine which are specific combinations of everything that can possibly help. I
We
think another
absolutely.
I
Yes,
think
thank
another
you.
really interesting finding that we have is that a lot of time there's a disconnect between preclinical and clinical
Yeah.
research because we're working with mice or rodents, and a lot of people ask, well, how does this relate to humans? Fortunately, our work falls in line with work that's already out there with humans. So there's a study done by Nat Schuster out in UCSD, and I'll give him a quick shout out. And what he found was that his team found that when smoked, so vaporized cannabis, a combination of CBD and THC was more beneficial than either cannabinoid alone, so CBD alone or THC alone. And that falls in line to what we're seeing, which is that when we administer CBD alone and we administer THC alone, we don't see a benefit. But when we combine the two, now we saw an alleviation of the migraine symptoms described in the paper. So I think that's very important, and that's where I see the field going in the future.
That's amazing. It's also amazing for me to see and fantastic this collaboration between different scientists around the world.
Mhm.
And please send um, all wonderful researchers to publish with our Journal of Cephalalgia and Cephalalgia reports. We're very honored to have you here, and thank you so much. We're looking forward for more amazing articles. Congratulations on article of the editor choice, Dr. Sacco. Thank you very much, and we'll see you very soon at the conferences.
Looking forward to it. Thank you so much.
Thank you so much. It was an honor.
Thank